Paul, this is our final video lesson in our first set of lessons, lesson 8, in our first, that's in the packet that was given to you before this whole crazy situation happened. We are going to be posting some review materials next week as well. This is the final lesson of our geometry unit, so we're learning about all the shapes. We've got over every kind of shape, and we're going to review it next week a little bit, and we'll try to find a way to make an assessment for it. I don't know how that's going to happen yet, but I'll let you know as soon as possible. So this is our last lesson on geometry, and then we're going to start next week with new lessons on measurement. And I'm going to make sure I keep you posted on YouTube, on Instagram with the new Instagram page. You can get from the link below in the description, or you can also go on Google Classroom as well, where everything is also posted. So stay informed that way. A lot going on. But I want to take a second, give some shout outs. We got some Khan Academy Masters this week. So Jana's leading the way. She's going crazy, mastering 15 standards, working for over an hour on Khan Academy this week. And Aaliyah, right behind her, mastering a lot of content as well, and Bella's there too. So great job to all three of you guys. Do an awesome job growing your brain any way you can. Keep it up. Also, want to update the Amplify challenge I told you guys about last video. So it looks like I'll be playing Fortnite on a computer and filming it. Don't know how that's going to work yet. I'm going to figure it out. I have a few students who've offered to help me, so we'll get there. It'll happen. That's going to be the next video I post. I got 5 students working at Amplify right now. So we've got Krishalise, Daniel, Christian, Bella, and Ashmita all logged in and going on that program. It's different. We've never worked with anything like it before, but I really want to try it with you guys, working in a different way. So let me know if you have any trouble signing in. I know a few of you already started texting me about that, but I'm going to come find you now. So the 5 of the people who got me going on this, great start. The rest of you need to get on now too. So the link again for the description of how to do it is below. If you're stuck at all, text me, call me. I'll try to get you as much help as I can so you can get signed in as well. So, yeah, this is our last video, and we're going to do this one before the Fortnite video. I think it'd be really make a lot of sense if I played the Fortnite video and posted it tomorrow, because tomorrow is Friday, which is exactly a fortnight since I saw you guys all last. Because to me, a fortnight is 14 days, so, or 2 weeks. So it's since how long since I've seen you, and I'll post that video tomorrow, and we'll see what happens. So for now, lesson 8 in your packet, final lesson, it's on symmetry. Let's get going. Open to your problem-solving task. So here's the problem-solving task for our lesson. It says Maisha sorted a bunch of polygons into the following groups. We've got group A and group B here. It says, based upon the chart above, how do you think she sorted these shapes? Explain your thinking. So take a second right now, pause the screen, look at those two groups, and on your own, try to figure out what the difference is between group A and group B. So when you look at those two groups, group A and group B, there's probably a lot of different things you could have come up with as the differences between them. The ones in group A, you could say maybe look like more regular shapes, ones you'd see around more often, whereas the ones in group B might consider like weird shapes. But we're looking for a mathematical difference, and this is unlike anything we looked at before, where we looked at angles, and we can't really find a way based upon angles to separate those two shapes, or based on the number of parallel sides. We have some with the same amount of parallel sides in both groups. You can't use parallel sides. It's something totally different. It has to do with changing the shape, okay, and how we can change the shape with the way it's set up. So take a second and look at it and see what you could do to one of those shapes in group A that you couldn't do to group B. Use that as a hint to help you. All right, hopefully you took a second to do that. And we're talking about this lesson is called symmetry. To be symmetrical means to be the same on both sides. So right now, if you look at me, I am not symmetrical because on one side I have a big part of this hat, and the other side I don't. So it's not symmetrical. It's not the same on both sides. But my glasses are symmetrical. They're the same on both sides. When we see it for a shape, what we're imagining is we're drawing a line down the middle of that shape. So I'm going to, well, not always in the middle, I should be very clear. It's not always in the middle of the shape. That's the one we're going to talk about as we go on. But I'm going to take a second, I'm going to show you what that looks like right now. Shapes in both groups. What I want to know is, how can I use symmetry to sort these out? So if you look at these shapes, I want you to imagine how they're the same on both sides or not. Take a second to do that. Hopefully you realized that in group A, they are the same on both sides. So that means if I were to fold this shape in half along a dotted line, right here, it would be exactly the same on both sides. I can even fold my paper to check that real quick along that dotted line and see that on both sides of that dotted line, I have the exact same shape. That's called a line of symmetry. Let's write that down. This is the line of symmetry in group A. A line of symmetry is an imaginary line that splits a shape into two identical halves. So this is one half and the other. That line splits them into those two halves. Another way to think of it, and it's not really a definition way of saying it, but is if you fold on this line, it will be identical or the same. It'll match up with the other side. So it has to match perfectly. So looking at the second one in group A, try to draw the line of symmetry in group A. Pause now, try it in the other one in group A. Hopefully you were able to see that. This line of symmetry in this triangle goes down the middle as well. It's an isosceles triangle. It's the same on both sides. If you go to group B, hopefully the first one is pretty obvious. There's not really, since the shape is so wonky, it might be similar on both sides, but you'd never get an identical shape if you split it in half. But the second one is a little weird is this one. It's a parallelogram, and it's not a rhombus. It's not all the sides are equal. But if you draw that dotted line across it in the middle, obviously it won't be the same if you draw it down the middle of it. But you can, some people say you can draw it diagonal. It's true. It is close to a line of symmetry if you draw it diagonally. But if you fold it over, it doesn't, I'm sure you can see through it, doesn't actually line up perfectly with the shape when you fold along the line. So it's close, but it doesn't fold up perfectly. So it is not a line of symmetry. So I would say no to both those shapes. Neither of them have a line of symmetry, though that one is pretty close. You can, like when you're working on paper, you can actually fold the shapes up to see if it works. If you're on the computer, you can draw the shape and see if it works. I want you to look at the next set of these shapes, though, and down here, and see that for some shapes, it gets a little bit more complicated. So let's go to the third one down in group A. Looks like basically a square, and a square, or shaped like a square, is special. Because I want you to take a second and try to draw the lines of symmetry in that square. Go. Pause the screen. Draw them. All right, hopefully you tried that on your own. But if you do this, if you wrote that it had a line of symmetry here, you would be correct. But if you wrote there'd be a line of symmetry here, oops, that's a bad line, you would also be correct. That's not all. Take a second, see if you can identify the other two lines of symmetry in that shape. A square has not one, not two, not three, but four lines of symmetry. You can see them all here. The 1, 2, 3, or 4, which means there's 4 different ways you could fold a square and have it be identical on both sides. Okay? So different shapes can have different numbers of lines of symmetry. All of group A has lines of symmetry. All of group B doesn't have lines of symmetry. We call these shapes symmetrical shapes, and these shapes we call asymmetrical. I'm going to write those words out just so you can see them. So we have symmetrical and asymmetrical shapes there. So take a second right now, turn to your guided practice. We'll see a couple other examples on there as well. We're in a guided practice now, and I'm going to go through this really quickly just to give you guys an idea of how to work through it. But you can see this is our first guided practice question. What is the total number of lines of symmetry in the figure below? Show your work. To show your work, all you need to do is draw those dotted lines that show the symmetry. As always, I want you to try it on your own first before you get any hints from me. So take a second, pause your screen, see if you can find where those lines of symmetry in this shape are. So always the first place I check is just top to bottom. And if you did this dotted line top to bottom here, you could see that it would be the same on both sides. So you have one line of symmetry this way. The second way I always would check would be just across the other way. And you can see in this shape, it's the same thing is true. Going across, it's the same on top and on the bottom. One that might be tricky is thinking about things being diagonal. And this is one of those shapes that where because it's identical on the top and the bottom and side to side, it does have identical lines of symmetry going diagonally this way. So you can't really fold the paper to check and see, but those add up to 4 total lines of symmetry for our shape. So looking down below that one, we see we have dotted lines. Are they lines of symmetry? Yes or no. One of those is, and the other ones are not. So you can go through and see which ones actually make a line of symmetry, look through, and which ones do not. Write them below. Pause the screen again, try it out. All right, we see that even though our first one isn't a shape that we've talked about, or even a polygon, in this case, because it has an opening, it does have a line of symmetry from top to bottom because if you fold it over, it'd be identical. The other two, folded over those lines, would not be lines of symmetry. It doesn't mean they don't have lines of symmetry. I want to be tricky there, okay? This is not a line of symmetry, but if they actually drew a line down the middle, right here, that would be a line of symmetry. If they drew a line side to side, that would be. This has 2 lines of symmetry. And this arrow, although it doesn't have a line of symmetry going from top to bottom, does have one from side to side. Enough to get you started with lines of symmetry. Continue with guided practice and independent practice on your own, trying to get those answers down yourself. I think lines of symmetry are a lot of fun. You'll see it, especially if you go into biology, studying things in nature, things that are symmetrical and asymmetrical. Really the way our bodies and bodies of animals are designed is really amazing in terms of how things are symmetrical. So hopefully you find it interesting like I did. And if you have any questions about it, you want to check your answers with me during office hours next Tuesday from 12 to 1, we'll be going over the lines of symmetry lesson and going over some